And we don't want to keep you guys here all night, so we're going to keep this flowing. We're going to get started. If you guys look all the way to your left at the screen, for those who aren't on Slack or the Meetup channel, we're actually running our own Slack for this Meetup. We want to keep the presentations rolling, so any kind of questions you guys might have during one of the speakers' presentations, log on and ask your question through the Slack channel. This way we can keep a tally. We can flow in with the questions. The idea is to really move every 20 minutes through a new discussion. So at that, if you guys have it on your mobile phone or you got machines open, log on. On the back is the Wi-Fi code. It used to be on that wall and it disappeared. So we're going to be closing the doors in about 30 seconds. Wi-Fi code zillions Q2 2016. I'm going to close this right here. All right. So guys, we want to thank you guys all for coming. My name is Dave Fredericks, one of the organizers, along with Dustin. We're really excited to be hosting here. And gracious thank you to our host, Wayfair. What we want to turn it over is housekeeping notes. Dustin wants to go ring through a few of the things that we have going on, so you guys have an idea of what the community has to offer. So this is Dustin.
Hey everyone, so we got a couple events coming up soon that we wanted to tell you about. Container Days is on May 24th and 25th at the Nerd Center in Cambridge. It's a really great two-day event. And DevOps Days Boston, we're doing it August 25th and 26th. Call for proposals and tickets are still open. So if you want to talk and share your experience, it's a great way to do it with the local community.
Yeah, we did. We rehearsed.
I'll let you talk about that afterwards. So we're starting to collect all of our different presentations and slides at bostondevops.org, all one word. So when you think to yourself, oh, that was a great talk 6 months ago, I guess I have to dig through the Meetup comments. That's why we're doing that. So we're going to be posting the slides and videos from tonight's event there, and also continuing this discussion and stuff. Back to Dave.
Awesome, thank you, Dustin. Hey, quick question. People were asking what the network is for the Wi-Fi. It's Wayfi, and the password is on the back, zillions, Q2 2016, for anyone that needs to log in. Obviously, you're going to capital Z, capital Q. Thank you. That's Bill Lincoln over there from Wayfair. So one person I want to call up representing Wayfair, just to talk a little bit about what they're doing here. She's been phenomenal in helping organize this event. Big, warm welcome for Kelly Hopkins. Kelly.
I did not expect this many people, so I hope it wasn't too difficult finding the place. For those unfamiliar with Wayfair, we are the largest online retailer of home goods in the US. What does that mean to you in DevOps professionals? All of our systems are pretty much homegrown, and the people that you see wearing these awesome t-shirts are the people responsible for our special sauce and what makes this a billion-dollar company. So definitely ask them questions about anything we have going on. We've been very heads down. We've been scaling to this massive company the past couple of years and really haven't had a chance to contribute to the greater engineering world, especially here in Boston. So that is a goal of mine this year. So if you ever have any questions, please reach out. I am a member of the meetup and posted all the directions today. So sorry about the annoying emails. We are actively hiring for DevOps professionals here, and I'm certainly happy to speak with anybody if they have any questions. I'd be remiss if I didn't put that in there, true to recruiter form. But I hope y'all have a great night, and please reach out with any questions. We are open to taking people on tours to see our virtual reality lab later in the night, so please come up to one of us wearing these black t-shirts if you'd like to see our kind of augmented reality and Oculus Rift lab up there. And then one other thing, we do have t-shirts for everybody here. So they are in the back corner of the room. They were a little bit hidden, so I'm afraid not everybody knew about them. So please feel free to pick one up. That's why we made them. All right, thank you.
Thank you, Kelly. So speaking of, we just want to let everybody know, Wayfair is one of our platinum sponsors, along with, I see G2 Technology going grab back there. We are still looking for sponsors. We got a lot of guys here. Brett Stack, I see you in the background. Got Tom with the Jama shirt on. Don't let that change your format. But if you guys are interested, on the board here, I'll show you, but it's bostondevOps.org, devopsday.org, excuse me. You can get information, or you can just reach out, DM any of the organizers that are on the in the list. We'd love to be partnering with any kind of organization that's really wanting to move this movement forward, I guess is the way to say it. So definitely come to me. We can talk. I can tell you the benefits that we have, and how it can be a benefit to you and your organization. So that's it. All right, we're behind. All right, there was Kelly, and you guys like how I like to use this. All right, so I explained the format for Slack. Now I want to basically get Dustin up here. He can talk about what our presentations are about today, and then introduce our first presenter. Thank you, guys.
Alright, so tonight we're talking about continuous integration and delivery. It's hard. You can do it a bunch of different ways. You're usually stringing different technologies together to do it. So tonight the presentations are focused on use cases, right? What people are doing in their everyday life to make this a little easier. And our first speaker is Richard Lee from DataWire, talking about continuous delivery with microservices.
Yep, here we go. Okay. Is this good? Can everyone hear me? Yeah. Okay, awesome. So how many of you guys are thinking about microservices in your company? Just a show of hands. And how many of you guys have actually deployed microservices? Okay, so maybe a third of you are thinking about it and less than a third are thinking about microservices. So what I wanted to talk today about was just around the relationship between DevOps and microservices, because like any sort of relationship, you can fall in love, but it's actually kind of complicated when you sort of come down to it. So I'm Richard Lee. I'm CEO, co-founder of DataWire. We are a startup company out of Kendall Square, focused on microservices. So I wanted to start with the definition of microservices. We've talked to lots of people. Some of the companies we work with are across the bottom with the obligatory logos. And we've learned a lot about microservices. And one of the things we found is that people, different people have different definition of microservices because people think that there are different techniques and architectures for microservices. So we came up with a definition that really focuses around the problem, because what everyone we talk to who is adopting microservices has as a problem is they basically have an engineering organization, they're trying to scale that engineering organization, and the way they try to scale that engineering organization is to break that organization into smaller teams, and they want to build an architecture for their cloud application that actually supports distributed development. Right, and distributed development doesn't mean everyone around the world necessarily, but it could be we have a whole bunch of teams and they might be all in the same building, but they're all working on independent things. And this actually turns out to be a pretty hard problem because you're building a continuously available system that's actually a distributed application. And so that's really, in our view, what microservices is all about. And so I think most people at this point have had some taste of the Kool-Aid around microservices. You take a big cloud application, the monolith, and then you break it into smaller little things called the microservices. And the key with microservices is that you're trying to iterate on each of these services very, very quickly, right? And being able to independently iterate on these is actually the key to actually driving your velocity forward. And so how do you actually drive your velocity forward and create independent iteration? Well, one of the things that's really important is actually having a continuous delivery workflow. And there's a few different reasons, sort of generically. Everyone understands that continuous delivery workflow helps you actually move from commit to customer much faster. But with microservices, it's almost even more essential because you can't actually test a microservice until it flows into production half the time. And the reason for this is because a microservice depends on other microservices, which might be running in production in different versions. And so you don't really know how well it's actually working until it's actually in production. And so if you have a very long cycle to actually get a microservice into production, your code, test, debug cycle can take a very, very long time. And you want that to be as fast as possible, which is why you want to think about building a continuous delivery workflow. So what does a continuous delivery workflow for microservices look like? So this is an opinionated view. It's not perfect. But one way to think about it is when you start creating a microservice, you start by defining your API. And so this is actually different from building a typical business application because you might start thinking about your domain model and data model. With a microservice, you think about your API first, right? Because that's how everything else is going to interface with your microservice. And then once you actually define that API, you produce source code, you code it up, you create source code, and then you actually build that source code. You create a jar or a gem or a node package or whatever you're using, a source artifact. You bake it with all its dependencies into an AMI or a container or a virtual machine, whatever, and then you deploy it on some sort of compute fabric, whether it's bare metal or EC2 or Mesos or Kubernetes, at which point you actually have a microservice running, and then you monitor that microservice. You need to connect that microservice to all your other microservices, and you kind of repeat this thing over and over again. And so in the blue is sort of what we view as sort of the domain of DevOps, and in the red is really more the domain of development. And you can see that there is a whole bunch of stuff you need in each of these different categories, and I'm excited that Barton and Ed are going to talk about Spinnaker, which actually automates your build, bake, and deploy later on tonight. But this is one way to think about the continuous delivery workflow and all the different pieces you actually need to actually adopt continuous delivery for microservices. And this is a very pretty picture, but unfortunately, it's actually not real. And one of the areas where it's really not real is really how I create this really pretty white line that's very thin and clean between the blue and the red. And there's DevOps folks who are on this side and then developers on this other side, and there's a clear delineation. But actually, especially in the microservices world, that's actually not true. And there's a question around what does actually DevOps actually deploy? And to get to that question, I'm going to give a specific example of how microservices are actually architected differently from status quo architecture. So I think everyone is familiar with your traditional n-tier architecture, which is tiers or something like that, right? You have a load balancer. That load balancer does health checks of your application servers. It load balances your available. Everyone's service. You start getting into have more than one microservice because you have to stand up these little mini environments with its own load balancer to start manually entering stuff into DNS, right? And you also introduce single points of failure with your load balancer because if your load balancer goes kaboom, so does your microservice. Now, of course, there are other chef scripts suddenly turns into 100,000 lines of chef, and no one actually wants to read 100,000 lines of chef. And so you just keep on adding to the end and hope no one reads the beginning, right? So, and not only is this actually a giant headache for DevOps, it actually doesn't scale, because when you start adding hundreds of microservices or thousands of microservices, you actually can't solve some very basic problems. You can't create the same environment between development, staging, and production, right, which creates its own sort of nightmare. And then updating microservices rapidly, which is the entire point of microservices, becomes really hard. You can't do a blue-green deploy in this architecture without, again, another 10,000 lines of chef. So, luckily, smarter people than me, like Netflix and Twitter and all these companies, have actually figured out a better architecture than this, right? And it starts with service discovery. And hopefully lots of you have heard of service discovery. But the general idea is you, instead of having DNS and load balancers, you have a store of your available instances of microservices. And that's actually sort of the linchpin of a microservices architecture. And Twitter actually was one of the pioneers of microservices. And you can see Brian Larson, he's an SRE at Twitter. And they did a reorg. And he was paged by 2 services he hadn't heard of. And he got very excited about microservices. And then, and there's a whole bunch of different technologies for service discovery. But Alex, who also works at Twitter, actually pointed out what the actual service discovery mechanism is actually at Twitter. So Twitter uses PagerDuty for service discovery. Just kidding. So seriously, so a microservices architecture that uses service discovery actually looks something more like this, right? So you actually delete all your load balancers, and what you have is you actually have smart endpoints. And these endpoints actually query your service discovery system, and they ask the service discovery system, hey, if I want to connect to this microservice named foo, give me all the instances of foo that are healthy at this moment in time, and then locally you make the decision around how do you actually connect to foo. And the reason for this is you now actually have built a distributed load balancing architecture with no single point of failure. And there are ways, and everyone goes, well, the service discovery mechanism is a single point of failure. But there are actually lots of clever ways to make sure it's not a single point of failure, which, if people are interested, I can go into. But it looks like a single point of failure, but it's really not. And so if you think about this architecture, what you've done is you've actually moved your centralized architecture, all the functions of your traditional n-tier architecture into a distributed model. So traditionally you use DNS for resolution, now you're using service discovery for resolution. You use manual entries into your DNS or an auto-scaling group if you're fancier for actually registering a new service, and now you actually have your endpoint, your smart endpoint, actually register that. You think about health checks, which traditionally are the domain of your central load balancer. You push that into the endpoint. And you also think about load balancing, which again was traditionally your centralized load balancer was responsible for load balancing, and now you also push that into the endpoint. And you've created a much more resilient distributed architecture. And so what does this all have to do with the continuous delivery workflow and DevOps and architecture and all this other stuff? Well, what's happened, if you think about it, is load balancers used to be the domain of DevOps, and now load balancer architecture is now shifted, potentially, somewhat into the software realm, right? And you actually want to think about how load balancing works when you're actually a software architect. And so if you think about the original premise of DevOps, I stole these slides from, I don't know, John Allspaw and John Hammond, or Paul Hammond, who actually did one of the early DevOps presentations in Velocity 2009. And if you haven't seen the presentation or video, it's actually really great. But he talks about how developers and operations, they need to work together, and he created these very funny slides, right? And Allspaw talked about how they got to 10 plus deploys a day in 2009 at Flickr, and he gave some very sound advice around building automated infrastructure, shared version control, continuous deployment, or CI actually, I guess if you say, well, one step build and deploy is continuous deployment. All this stuff. And it all makes sense today, and I think a lot of people have actually internalized this. But if you think about microservices, this is necessary but not sufficient. And microservices, it actually requires much more meaningful collaboration between the software architects and your deployment architects. And I hope that this example around load balancers actually just gave a very clear example of how you can't actually just build your software architecture and then go and talk to DevOps around how you actually deploy, right? And it doesn't just talk about load balancers, it's also how you think about resilience, how you think about monitoring, how you think about API design. All these things actually, what we found is requires a much higher level of collaboration between your DevOps group and your developer infrastructure group. And you need to understand, like, we actually work a lot with the folks at Yelp, and their developer infrastructure group has a very, very strong understanding of things like latency versus availability trade-offs. And they design their infrastructure for the developers to make those trade-offs actually visible to the developers so they can actually do the right thing when they're building the application. And so, if you actually get to this meaningful collaboration, you will find true love. And as everyone knows, when you find true love, there's no happy ending because true love never ends. So in summary, so a continuous delivery workflow, it's essential for microservices, and building this workflow actually has implications for both your software architecture as well as your deployment architecture. And if you actually create this collaboration, which I think is essential for success, and all the companies we worked with that successfully adopted microservices has a strong collaboration, you will find true love. So anyway, so that's my little spiel. If you're interested more in microservices, DataWire, we're focused on microservices. We do a lot of work around pragmatic architectural design and deployment. So go to microservices.com for our Microservice Practitioner Summit, where there are videos of really great talks from Facebook and Uber and a whole bunch of other companies. We're actually having another summit in July, which if you sign up, you will get first-hand knowledge of the summit. If you're interested in beta testing some of our open source software, you can send me an email at richard@datawire.io. And the obligatory, how many people here are recruiters? I bet like a quarter of the group. Okay, only one person's brave enough to wave their hand. I guarantee like there's more than one recruiter here. But anyway, so if you go to datawire.io/careers, we are hiring as well. So anyway, happy to take questions.
So, Rob Park,
What?
you want to ask your question?
Oh, sure.
Yeah, you said it. You're right there, so.
Okay, yeah, ask me if you, like the central point of failure, so why is a service discovery unit?
Oh, why is the service discovery unit not a single point of failure?
Console as opposed to having, 100 ELBs.
Yeah, so the question is why is service discovery not a single point of failure? And the reason, it all depends on how your design works, but usually what you do is you put essentially what is your routing table into your service discovery framework, right? So that's actually your mapping between a service named foo and all available instances, and that's in real time. And then what you do is you actually propagate that to each of your endpoints. And so each of your endpoints maintains a copy of that centralized routing table. So what happens is if service discovery goes kaboom, all your local clients are still able to do their routing because they have a local copy of the routing table, so there actually is no single point of failure. And then what happens is then as soon as your service discovery system comes back, it starts propagating updates again. So this is how, so by the way, this is not how Zookeeper, if people are thinking about using Zookeeper console, actually works, but this is how Netflix Eureka and Ribbon actually work, and it is a much better way to actually work. Netflix Eureka actually, trivia fact, used to actually be architected in a strongly consistent system like console or Zookeeper, and then there was a network partition and they couldn't roll out new instances and caused a global outage in Netflix, and so therefore they rewrote their service discovery mechanism to be eventually consistent, which is the right semantics for service discovery. So don't use console or Zookeeper for service discovery. That's the lesson. Even though everyone tells you. Ribbon. So Ribbon's the client, Eureka is the...
So next question from Neil Patel. If you're doing load balancing in each app, how do you ensure that the load is actually balanced?
So it turns out round robin actually works reasonably well because it's actually distributed and people, it's the equivalent of randomized. And also what happens is because your health checks are actually giving you data on what's available, basically your health checks actually help you figure out when an instance gets overloaded and stops responding. They're more sophisticated mechanisms for this, but in general it actually works reasonably well. Twitter, for example, and then that's sort of your generic answer. And then if you want to do something more fancy, companies like Twitter have actually developed some fairly sophisticated, more advanced load balancing algorithms. But I would say that you're pretty, it would be unusual for most companies to actually hit that kind of stuff at this stage.
All right, any last minute questions?
All right, thank you.
Richard, thank you so much. And for anyone, we'll have Richard's slide deck along with his direct messaging up on the site. So if you guys have any questions that you want to, ask later on, you'll be able to read them through the meetup site.
All right, thanks again, Richard. Up next, we just keep on going. Dan Rowe from Wayfair is talking about Wayfair's evolution, and we'll highlight the tooling and workflows used to deploy multiple times a day at Wayfair. Welcome, Dan.
Good? Hear me? No? No? Yes? Yes? All right. All right. I thought I was after the break, so bear with me a second. We're all here? Okay, great. A lot of these talks you come to, and it talks about this new shiny tool that we just pushed out, and it's super exciting. And you don't really get a lot of the background of how they got there, or why they have that new tool, or where their origins are from. So I'm going to take a quick step back and talk more about how we got to where we are. I'm going to stop using my hands so much. How we got to where we are. And we didn't start off with a fancy super deploy system and all the other features like that. So let's go through that. A little bit about me. I'm Dan Rowe. I work at Wayfair. I lead the InfraSWAT team. A lot of people ask me what the heck is that. Essentially, we're a projects and consulting type of team. The goal of the team is not to own anything. Owning things slows down your momentum, right? You say, hey, I want to use this new tool or this new system. You push it out to production, and now you own it, right? And so now a portion of your team is kind of reserved for troubleshooting that, fighting fires, waking up in the middle of the night, working on it, all that stuff. Our goal is to, hey, there's a system that needs to be fixed, re-architected, etc. We'll go in, we'll help design the re-architecture of that or what replaces that. We'll work with the team that owns it, and we'll kind of push that forward and get that released. And kind of ownership of the team will remain owners of that. We won't. Same thing with POCs. We're working with a new technology. Somebody says, hey, I have this science project, can you guys work on it? We'll work on it. If it looks like it's got legs, we'll spin up a tiger team. One of my team members will kind of lead the team with a couple of cross-functional engineers. They'll work on it for a period of time, and then ownership of that will be either a new team that's spun up from that team or an existing team will take ownership of that. And that's kind of how we maintain our momentum without the operational end of it. And so far it's working out really well. A little bit about me. I love all the stuff that we're talking about today. I've been building deploy systems since before it was cool. I'll show you some of the sketchy systems that we had from the beginning. And then I'm passionate about making everything self-service. There shouldn't be any red tape, there shouldn't be any friction, whether it's a developer, whether it's a systems guy. I have something, I know how to do it, I want to get it done. sure, give me some guide rails or some guidance, but don't get in my way. Sorry, I should have had the hand wave. Okay, we're good. We're good? Alright, okay, alright, so passionate, that's me. Whether it's metrics, monitoring, alerting, deploying, the developer is the one that's writing the code, knows about the code, they should be the one adding the metrics, StatSki. I helped scale that with StatSki Proxy, if you're familiar with that. We pushed out StatSki CC as a Wayfair open source project. We take metrics very seriously here, but if a software engineer pushes a metric and they're watching it, they're not always going to be watching that metric, they're going to be coding the next feature. So giving them the ability to add their own monitoring, alerting, things like that. And the same thing with deploying. A developer writes the code, they should be the one pushing it to production and making sure that it's running the way that they think it should be, and they're kind of responsible for when it hits production and if something goes wrong. It's not a throw it over the fence kind of scenario. And then, I have biology major by degree, I guess, specifically reptiles and amphibians. So I'm comfortable with Python as well as Pythons. I'm a big snake and monitor breeder, so if you're into reptiles, happy to talk about that too. But we'll stick with tech today. All right, the evolution. So we're going to talk about the evolution of kind of deploys, the collaboration, as well as testing and tools. And so, going from the Stone Age all the way up to fancy chainsaws and that kind of thing. All right, evolution of deploys. We said it, we grow fast. Wayfair moves fast. We iterate and improve on our tooling and our workflows just as fast as we do our new features to the site. And we didn't start out with that fancy deploy system. It's come a long way from the beginning. So the early days. I wouldn't call it continuous deployment or any of that. I would just say rapid deployment. It was just make a change, push it, hope for the best. We had a server. We had developers using Windows SourceSafe, if you know what that is. And the way that we developed was an engineer would check out a file, so nobody else could edit that file, and then they would work on it. They'd get a code review, they'd check it in, and then they would drag it, drop it to the FTP server, and that was in prod. Magic, right? Then they'd hit F5 real quick to make sure the site was still up. If it was, they'd celebrate and then go on to the next feature. If it wasn't, they'd drag and drop the old file and F5 until it was back up. And that was production. It was kind of like running with scissors, but we had a really, really low mean time to recovery because of that, right? We had a small engineering team. We knew when a file was going up. They knew what change it was. They were checking, and it worked for a small team. As we scaled traffic-wise, we kept very similar to that model. We added more servers. Developers still had FTP access. But we needed to get it to a bunch of servers. So we kind of set up a Windowsy rsync batch file. Yeah, it was scary. But I got the code all to the servers pretty quickly. And again, it was upload, cross your fingers, and because it's going to a bunch of servers, cross your toes too. Check the site. If it's up, great. If it's not, roll back, iterate. And we scaled the team and the number of servers a significant amount at that pace, and it just worked, right? There wasn't any testing other than kind of the engineer doing their testing in dev and verifying in production, and it was a way for us to rapidly add features and scale the company as we went. All right, that only goes so far though. As you get more and more engineers, you kind of, FTP does a great job of knowing when a file went up there, but it doesn't really know what the contents of that file was, right? So you say, hey, yeah, that file got uploaded 27 times today, but I don't know what version or what contents of the file, so we really needed to get integrated with SVN and Git. Also, we had scaling problems with our syncing batch jobs, so we needed to kind of solve our replication issues. And so we built a deploy tool with an agent, so that each server had an agent on it. That agent was super dumb. It says, I know I have this application on my server, and I'm going to pull a REST API. And I'm going to say, I have this application, and I'm on this version. And either the central server is going to say, awesome, talk to me in a little bit, or, oh, wrong version, you need to be at this version. It didn't care if it was pause forward, backwards, revert, push forward, it doesn't matter. It would just say, what version should I be at? If I'm not at that version, I'm going to get at that version. So simple, very simple agent. We have for Windows, Linux, it could do Python, Java, ASP.NET, etc. It was awesome, and it prevented the dreaded accidental drag and drop. Right, so developer has FTP open, accident, click button. If you've ever used FileZilla, it's pretty easy to drag and drop a folder, and then all of a sudden a website disappears from the internet. Yeah, it was bad. But building this deploy system where they were checking in and we were having to kind of package up these tar files for them to pull down, gave us the very beginning of a deploy pipeline, right? If we're going to write tar, said code files, we could write other things during that steps, right? And so that was kind of the very beginning of our deploy pipeline. It also solved auditability, like I said, knowing who pushed what when and what the contents of that. A sidebar is we had an outage. Somebody we didn't know pushed file, wasn't checked in, and so we were trying to figure out, what happened, file changed, but it wasn't in source control, so we figured out what file it was, we reverted it, sites came back online, that was great. We went through the FileZilla logs to see who kind of pushed it, and we sent out an email saying, hey, who pushed it, nobody raised their hand. We went to the person we finally found in the FTP logs who had logged in, and we said, hey, Carl, did you push this file? And his response was, you can see that? Needless to say, we weren't working with Carl very much longer after that, but we needed the auditability of that to going forward. Alright, so we have this pipeline, the very infancy, we're tarring files, hey, this is awesome, what should we do next? Quickly thereafter, developers are writing unit tests. Why not? We should run those as part of the deploy process as well, just to make sure that there's no naughty developers that didn't run the test before that they pushed in their code. And then after that, we added Selenium tests. We'll talk a little bit about that. And then, hey, we're running these tests, why not add staging so we can kind of push it somewhere, developers can verify it there before it goes to production. And that was kind of the way that we iterated and improved. And this was great for developers, except on the Selenium side, it was really hard to test or debug. And so we'll talk about that in a minute. All right, so you get to the point where, hey, we have a web UI, developers are pushing, they can push their change anytime they want, once it's code reviewed. This is awesome, everybody loves this, right? You get a couple hundred developers, and now all of a sudden, you're deploying, say your deploy takes 2 minutes, you don't have enough minutes in the day to deploy code. You have that many changes going out. And all of a sudden, your changes are stacking up right after each other, and there's no time between deploys to say, is this change, or is the errors we're seeing now my change, or the previous change, or the person after me's change? And there was kind of a backup when there was a problem, because it took a little bit longer than we would hope to figure out which one of the last 5 deploys was this problem from. And if I revert that change, is anything else that got pushed after that relying on this change? And so we needed to rework that. And so the way that we did that was kind of an iteration on the trains model, which essentially is you have a deployed branch. We create a branch that say it's the 9 a.m. branch. If your code is ready, you push it onto that branch. At 9 o'clock, that branch gets closed. We run the tests, the unit tests, the integration tests, the Selenium tests, all of that on there. Everybody on that train is in the deploy channel, and it goes out. It goes to test staging, and then if everything passes, it goes to production. One addition to that model, compared to some other companies, is we have a conductor. And the conductor is kind of like a release engineer, except he's primarily just the driver of the branch from those different stages. And he's got the big red button. So if at testing, at staging, or at production, if he sees anything weird, performance-wise, errors-wise, alerts, anything like that, he hits the big red button and it reverts. Primarily it reverts on production to the previous version. And the reason we have a conductor is they are aware of kind of all the pieces of the application. Whereas a developer, if I'm in the search team, I'm very focused on how my feature for the search that's going out is working, but I might not have noticed that somebody else integrated with my code more tightly than I expected, and it's breaking some weird place over here. The conductor kind of has a better overall understanding of all of the monitoring and alerting, and so they kind of have a bigger picture. And they are the ones that can say, hit the red button and revert. And they're also, because they're unbiased, they don't have any code on the train, they're not going to be like, oh wait, I know what that is, I'm going to fix it. So 5 minutes later, 10 minutes later, 30 minutes later, that I can fix it issue kind of prolongs the time that we have an issue in production. If the conductor hits that red button real quick, then they can troubleshoot, do whatever they want in staging while production is fine. And so that's how the conductor kind of helps us in that area. I think I covered all this stuff. If you have any questions about the slide when it goes online, happy to talk more on kind of all the different pieces. But that's trains. All right, and that's the deployed thing. Let's talk a little bit about collaboration and testing and the evolution of that. Deploying fast is great. Deploy trains, engineers can push their code, all of that. But we really needed a way to show each other kind of what our changes are doing. This included other developers, whether it's like, hey, can you validate what I'm doing is correct? Is it working? Is it doing what we think it should do? As well as kind of the business and the creative users. And this kind of evolved over time as the team scaled, as the business dynamics changed, as well as kind of as more locations. At Wayfair, we kind of expanded to different locations. All right, early day collaboration. If you're in the same room and there's only a few of them, come over here and look at this. That's easy enough, right? And that still works today for the teams that are all in the same building. But it didn't really scale well as we grew. So we added something we call the dev switcher, which in this whole big slide is just that little guy over in the corner where it says master. What that is a drop-down. If you open the drop-down, it's a full list of every engineer at Wayfair. And by clicking that, you switch to their development environment. So their kind of active environment where they're actively coding. Master is a set of servers that just track master. So if you just want to check to see what the state of dev is, that's the default. But say you wanted to check, hey, Dan is working on this feature, and he asked me to check on it. I'm going to go switch over to Dan's computer, and I'm going to work as Dan or work as Bob or whoever I want to work as. Log in and test that feature. And this was great. This gave the business and creators the ability to kind of check on the features before it went somewhere else, and the collaboration was easier between offices and things like that. But the problem with that was as the business side number of features scaled, as the number of engineers scaled, as the number of things each engineer had to do scaled, there became this kind of lag, right? So I'm engineer, I have feature A, I tell the business person, hey, can you QA this, can you test it? They say, sure, but I have a meeting for an hour, so I can't get to it for an hour. Well, this is my dev environment, right? So I can't switch branches, I can't work on the next feature until you QA it. Or I have to switch branches, do that thing, and then you're going to ping me in an hour saying, I don't see your feature. And I'm like, oh, wait, let me switch back to that branch, right? And so this scaled really well and was a great innovation at the time, but we needed kind of like the next step. And so the next step was something that we call QA Git. And what this is now there's a ticket, right? So ticket comes in, I need feature X. Okay, I'm going to create a branch with ticket X as part of the branch name. And if I do that, when I go to that ticket, there'll be a test now button. And so at any point in time, I can hit the test now button, and it's going to pull me up VM with that code base of that branch. And so a QA person, a business person, a creative person can kind of check out that branch and see what the person is working on, validate the features without holding up the engineer working on their own development environment. And this really kind of decoupled that two pieces and kept our engineers working forward while the business can take their time to kind of QA and feature validate. So that's no more waiting. All right, so we talked a little bit about our Selenium problems, right? Selenium is great if you're using it and you have a good framework and all that stuff and your grid's up and your browser compatibility, yada yada. And so at the time when we first started this, it wasn't really a good framework in PHP. Since we were a PHP shop, we wanted to be able to write our tests in PHP. So we grabbed the Facebook SDK and we wrote our own framework around it. We called it Autotest. So it was managed by a small team, and unfortunately it was very comprehensive, which meant complex and a really huge learning curve with very little documentation. And so that meant anytime we needed a test created, added, updated, fixed, whatever, that team essentially got called in to do that. And so it gave us a lot more confidence than we had before because we were actually testing stuff before it went out and after it went out. But it broke often, right? So if your team that is designing these tests is separate from the team that is changing the website, a change to, say, add to cart button, right, goes out, and you don't know if that test is broken because the test is not valid anymore or because actually the functionality. And so there was a lot of firefighting on the testing team because they had to kind of always check, hey, is that a false positive or that what? And so that didn't scale very well. And so not too long thereafter, we pulled in an open source project called Codeception, switched to an open source one, much better documentation, much easier to understand, write your own tests. We also worked on developing kind of the training the developers to be able to write and run these tests. And so this was kind of pushing the responsibility of these tests out to the people that were writing and maintaining these features, right? So if I'm the person that's maintaining the add to cart functionality, then I should be the one maintaining the test that verifies that. And so this was something now, if I'm going to modify the add to cart button, I'm also going to modify that test so that when I push this out, they're going to both go out together and everything's going to be happy and green. It also freed up the testing team to add improvements to the framework. Instead of kind of always firefighting these tests, you could build new systems, new helpers, new libraries, things like that. An example of that is, early on, you have a test that says, okay, I need to find a product that has options, so like color options or whatever that might be, and I'm going to pick an option, pick a quantity, add to cart. Very frequently, you would pick a hard-coded SKU or product ID, you put it in your test, and that would work for 6 to 12 months until that product was back-ordered or out of stock or discontinued, and then your test would randomly fail. You'd be like, hey, that's awesome, no. So let me go in, fix that test with another hard-coded SKU. And so an example of there, they provided a helper, right? So it says, find me a product with this set of attributes, and that's what you're going to run the test against. And so that very quickly reduced the number of false positives that the test would pick up. And so those are the kind of iterations then that the testing team was able to add once they were out of firefighting mode. All right, and the last thing, so now we're almost done. Just a tool. So now we have, the deploy train, we have review board is how we kind of get our code reviewed. We have Selenium tests, we have unit tests, we have joining trainings, we have a bunch of different things that a developer has to know how to do. And it's more than a handful of different command lines with different options and all that stuff. And so with the onboarding of new engineers was kind of tricky because of that. If you're like, oh, use this tool, use that tool, read this 1,000 KBs, and then you might be able to start. It got farther and farther away from that, hey, first day, commit code, hit the deploy button, and you're good, or drag it, drop FTP. And so we created a command line tool called Wayrunner, or the Wayrunner, that gives you kind of all of that functionality under the same place. It's not that you have to use this, it's just speeds up the onboarding of new developers, and then as they go, they can kind of figure out their own workflow from there. A really nice thing is, hey, I have a code change that I want to get reviewed. I can say, okay, send this to review board, send my changes to review board, but make sure you send it through all the tests first, right? And so it'll send it through unit tests, integration tests, Selenium tests, and it'll post to review board. And after all those tests run, it'll post the results to review board as well. And so when I'm a reviewer, I can go in, I can say, hey, all of your tests passed. I don't have to check for syntax errors. I don't have to check for code style. I don't have to check for any of that stuff that isn't important for the business feature or functionality that you're trying to modify now. And so it really streamlined a lot of the review process as well, and reduced a lot of the semicolon, this is a tab, no space, all that kind of stuff that was in the early reviews. It does implement a lot of the try functionality, so if you're not familiar with it, Mozilla, BuildBot, and Etsy has kind of their own iterations of that. We have that functionality in Wayrunner as well as a lot of other helpers. All right, I think, again, so we're never done, I'm almost done. But testing containers kind of as a next option, right? So we're iterating, we're deploying new code. How does containers in this new world fit into that? Can we move to that model? Whether it's just on the VMs for developers, is it part of our kind of continuous deployment testing iteration? Is it in production in the future as well? Same thing with local VMs versus centrally managed. So we showed you that drop down that showed you a list of all of the developer VMs. That's kind of all centrally managed, but all developers have a beefy laptop or desktop in front of them. Why can't they run that VM locally? And so figuring out how we can get our stack or some portion of that stack running on a developer's local machine, so the latency for their changes and things is much lower. For us, it's fairly complicated because we have a fairly large number of integrated systems that span Linux, Windows, etc. and trying to get like 30 or 40 different SQL Server instances on a local VM is not pretty. But baby steps. And then again, many, many more things. We rolled out a change from, hey, we used to say all your code was mounted via NFS on your VM. If you try to rsync from your workstation to your VM to NFS, it would take about 50 minutes to do our whole PHP repo. Got rid of the NFS mounted as local to the VM by just expanding the VM case, and it went down to about 2 minutes. So just kind of always iterating, improving the way that the developers work, as well as kind of erring towards developer happiness and frictionless development. All right, and that's all I got. So like the last slide was, we're hiring. People in the back can't see it, but we are. So if you have any questions, I guess they leaked that there's a lot of these shirts. I was going to say just find somebody in one of these shirts, but now that could be anybody. So just find somebody from Wayfair, and we'll be happy to talk to you about all the cool projects we're working on. Most of my team is up here heckling me from the front. If you have any questions, you can talk to them about the InfraSwat stuff. If you have any questions about my talk, we can talk Slack either now or after.
Anybody have any questions for Dan? It's your time to ask.
Uh-oh.
So I heard this rumor that the database schema that Wayfair has is about 1 gigabyte.
Yep.
Are we
And it's still
gonna,
an SVN.
oh yeah. Are we going to have a talk about how they do deployment on that?
Yeah, we need to switch it to Git first. But the reason it's not in Git is because the way that we apply schema when we deploy it is very incrementally. And so SVN works awesome for that, right? You just say next version, next version, next version, next version. And so the deploy tool needs to be updated to be able to handle the next commit, next git commit, next git commit. And we haven't done that yet. If that answers the question.
Given that you're using the deploy train,
Yep.
don't you start running the reverse problem of more frequent deploys?
Don't you get the reverse problem of
Just to say, you start getting larger and larger batches going out, which minimizes the effectiveness of doing CI/CD by having larger batches instead of smaller batches yet again.
Yes, so it's definitely ebb and flow balances type of thing. One of the things is right now we do say about an hourly deploy, right? Which gives us a pretty big buffer between the next one. We could easily shorten that gap, as well as shorten the gap. We're always working to shorten the gap of the time it takes to deploy and run through all the tests. So that is definitely a future problem, but because we're at an hour at this point, we have a pretty big buffer before we get to a point where we think each deploy is too big. I'll give you an example though. During the code holidays, right? Some people do a code freeze, do all that stuff. We usually just say afternoon trains are off for this week or whatever, so we do all our morning deploys. And you definitely get some of that effect where, hey, everybody needs to get their code out on a morning train, which means those trains go from maybe 10 to 20 people to 30 or 40 people. And the train conductors usually have a little bit more time to spend in staging and test to make sure that everything looks good before it goes to production. But you do tend to have more errors once you get such big trains. A way that we do that in the holidays is add an earlier train or two to kind of help dilute the bigger trains. Good question. Okay, go.
Dan, thank you so much.
Thank you.
We have a 10-minute break, grab some cookies, some drinks, and we'll be back here in 10 minutes.
About to present Barton and Ed talk about their Spinnaker POC.
Yeah, Barton.
You guys got a mic?
You got the mic. Pass the mic.
I'm passing the mic now. Anastas, how you doing?
All right.
Yep. Hello. Check. It's Barton Nicholls and Rousseau. We work at SimpliSafe. Also, like everyone else, we're also hiring.
Mark, speak up. Speak up.
Should I? Oh, there we go. So, Barton Nicholls, Ed Rousseau, SimpliSafe, like everyone else, we are also hiring. It's not on the site. So, where did we begin on this? So, I came into SimpliSafe about half a year ago. We had a decent system, but it was a little cumbersome and isn't going to quite keep up with the growth patterns that we're looking at. So, what did we want for a new system? These are our requirements. We want it to be infinitely repeatable, self-serviceable, baseline matches production, best-in-class components, low cost of maintenance, and have it be extensible. Sounds pretty good, right? Where are we now? Our infrastructure code is owned and operated by ops. Developers are mystified by the process. Communication around infrastructure withers on the vine, so we have a lot of missed opportunities, and so on and so forth. What are our next steps? What are we looking at doing here? We want to empower the end user. We want to get out of people's ways, make it easy, free up all of our times, and reduce animosity. Boom. So, what did that bring us to? So, we went to CloudFormation. We're tenants of AWS. We had been using, well, we can get into a little bit where we were before, but decided to go with best-in-class tools for AWS. This is our entire infrastructure. We'll cut off here, but there's about 10 layers to it, and it takes about 7 minutes to spin up as a stack. A little bit of the parent template there. And as soon as it's up, we go over to Spinnaker, and there it is. It's ready to be interoperated with lifecycle for the end user. Gets people out of the AWS console. Not a fun place for people that don't know their way around. Not warm and fuzzy to give everyone access to. So much better way to interoperate with it. So Spinnaker makes a couple assumptions. Show of hands, who here in the room has looked at, done any work with Spinnaker? 7 people. So it's a pretty new tool. Documentation keeps evolving. I started on this about 2 months ago. There was 0 documentation.
What is it?
What does it do? Spinnaker. So Spinnaker was written by Netflix and Google. Some think it was probably a shot across the bow of AWS for Netflix to get out and say, hey, we could leave you at any time. It's cloud agnostic. It is a continuous delivery layer. It does not do everything, but it does one thing really well. It makes a lot of assumptions. Personally, I think they're pretty good assumptions. They want you to create your artifacts and package them up as RPMs, Debian packages, what have you. They want to then install that package on a base AMI and turn that into base image and turn that into AMI. Essentially, and I'll let Ed talk about this a little bit from a QA perspective, but to encapsulate that in time with metadata so that what you start with is the same thing that ends up in your production environment. So I think going back a little bit to these slides, right now we had, if a developer wanted to spin up an entire stack, that was something that required operations to find the time to do. Probably took a couple days. Probably had to twiddle around with it a little bit to get it working correctly. Not a fun experience for both parties involved. Here, obviously, 7 minutes and a little bit of this, and there you are. You've got your environment, and you can start mucking around with it. The other component that we're using here is we use GoCD. We're not a Jenkins shop. And this is just an example of a job that looks at a particular Git repository, looks for the change, pulls it down, creates a RPM out of it, pushes it out to our Artifactory, and kicks off the pipeline that will start a process whereby image is brought up, RPM is installed, a AMI is made of it, and that AMI then repopulates the auto-scale group. So, what are the results? Infrastructure code is still owned, secured, tested, maintained, analyzed, agonized, monitored, refactored, philosophied, demystified, renounced, revoked, refinished, reorganized, and rethought by ops, with two main differences. And I'll hand it to Ed here.
All right, so the difference is the conversation about infrastructure. You can talk with it with your stakeholders without first saying, no, we can't do that. Right? So it makes making the changes that your stakeholders and the business wants a lot easier. So you can go to those conversations not sweating bullets, not saying, oh, how the hell are we going to do this? But by saying, yeah, we could probably do this, and here's how. The second, the stakeholders only have to know what's possible. They don't have to know all the guts of the lift. And that's important because that's kind of where we were coming from. So you might ask, okay, Ed, why did you guys decide to do this project now? There are a couple of reasons. So in the last 18 months, our engineering team has grown 3 times the size, and we're going to keep growing. This means a whole lot of new roles and new people were coming on. Our original infrastructure was Vagrant Puppet Terraform, and was really optimized for how can a developer get a production-like environment to work on their laptop. Which is not a bad place to start, right? If you're starting out, you're like, okay, we've got production, how do I mimic it here so developers can develop against the same type of environment as production? There's some problems with that as more roles come on, and you need to build out more environments. Me being a QA person, I like load test environments. I need different things than production in there. I might need something I might be just testing one part of the service, so I need that service and maybe a bunch of mocks. And then I need my load driver, and I need a few other things to catch the metrics at the back end. That's a variation of production. There's other variations I would need for testing to get data back to the business about how things are happening, and that's different than what the system was optimized for. The second piece was, currently, our team is a lot more comfortable working in AWS versus working like in a Vagrant environment than they were at the start. At the start, a Vagrant environment is like, okay, you're just on your laptop, having to do things with AWS Console and things like that, not super comfortable, maybe not really getting the whole kind of cloud operations concept. Over time, they learn things. So they're a little more comfortable with that. And again, a need for a larger matrix of infrastructure beyond your just dev stage part. Load test, integration, things like that are needed as the team and the infrastructure scales up. We need to refactor anyway, right? So trying to do this variation in our current Terraform environment was difficult because of inheritance and scripts. It's all over the place. So somebody like me who wasn't there when it was set up and is trying to look in onto this code and say, all right, I need an environment, but I need these 3 services from the prod branch, this service from the dev branch. I need to stand up 2 other load drivers, a backend listener for the time series data. Oh yeah, and I need to be in different security groups, and I want to be in a different region and my own VPC. How do I do that easily? And really, without entirely kind of refactoring how that worked, there wasn't really an easy way. It was like, okay, Ed, you can spend the next month really digging deep into this Hub and Terraform code and really learn it and internalize it, or we can do something easier. And that's because while the instances of things that got pushed out, the result were cattle, the actual scripts themselves were a bit of a pet, right? So you have, you could run the stuff and in about 30 minutes you could get a full stack for production under our old system, right? But if you had to make a change or a variation, that took a lot of lift to verify that it would work as intended. That you had to actually, hand tweak it, that didn't quite work right, so, let me go in and tweak this script here and this over here, and that variable's off, and boom. So the infrastructure is code, deployment's also code, that code needs to be tested, refactored, all those things. Don't make your deployment code a pet. The other thing that we were doing that this would change would have, instead of code being promoted from environment to environment, dev stage prod, you'll have artifacts. So in the current system, you kick off the job and everything gets built from source. You supply the commit shop of each service that you want. That's a revision. Boom, it goes, it builds, it provisions, it goes out. Now you think, okay, maybe that's good, right? We have it tied back to code, that's the code that's in production. But the deployment scripts are versioned differently than that shop. So if you deploy, let's say, to stage one day, and you have a change that happened in that Terraform deployment scripts, and then you deploy to production, you've got drift. That's not the same. The results are not the same. It did not go through the same process that you verified and tested on stage that went to production. So that is why you want to always have artifacts go through, because then you know that same package thing is the same thing that you tested in your various test environments before you put out in production. And lastly, what we really wanted to do is red-black deployment capability. Red-black. I'm wearing black. Red-black.
We're not that.
We could dream. Yeah. So with all that, it was like, okay, let's take some time to think about what we could do other than just hack on our original infrastructure. So, go through the Spinnaker POC. It looks very good. Thank you, Barton. You're going to make my life a whole lot better. What are the benefits that we see from kind of the QM engineering point of view? Big one, easier definition and maintenance of the varied environments, multiple integration, low test environments, variants and regions, security groups, deployed mocks, and rules for spin up and spin down. That's huge. That's huge. Because now it becomes no big deal to spin up a complete variant of the infrastructure here and then spin it down. It's like, oh, well, I want to try this out and tweak it a little bit this way. I can spin it up over here. Not so much, spin it down. So that capability gives us a lot of flexibility in the way that we develop and test. Big thing, QA guy, build artifacts promoted. Not good. So it's better confidence that what we tested is in the environment that we deployed it to, right? So it's the same thing no matter what environment it is. Okay, so it also makes it very easy to share that artifact between environments, right? So that means it's like, oh, if it's just an AMI, okay, I'm gonna spin it up here. I'll spin it up here. Oh, somebody has a new environment that they want to check this out in? What's the name? And that reduces the risk of environmental drift between environments. And last, we can get provisioning and self-service. So we'll be able to push a button to stamp out a new environment rather than having to hack variables in scripts in some configuration files. That is always a bad thing, in my opinion. And then those variations that are created by different people, those are easily shareable, right? Templated. So if I find something in integration or load test environment I want, I don't have to keep that environment up. I can just hand that off to a developer and say, hey, why don't you use this to check out your new code before you actually push it off? I'm having some problems with this. It makes it very easy for me to share that. It makes it easy for me to share the test assets that I build in my environments with development so they can get that early. I think it's a win all around.
Also, actually, there's one thing I thought about as you were talking. I think, oftentimes we have questions we want to try to test out and we want to get an answer to, and if the amount of time it takes to get an environment up to ask that question is so onerously long, it makes us not want to ask many more questions, right? I mean, if you can get your environment up quickly and you can go to work on the problems that you want to solve for, you can solve it quickly, you can move on to the next problem. I think that's a big one as well. So, here's the building blocks that we use here. GoCD works, used to be cruise control, that was Go, it's GoCD. The effing package management. Polite company. So Artifactory is probably the only paid for here. Solves a lot of problems for us beyond just Yum and Debian packages. CloudFormation, I think it's, my thoughts on, there's a lot of agnostic tools, but they end up being a little kind of lowest common denominator, and they break when CloudFormation, which they usually hook into, changes, so why not just use the tool that's there? And Spinnaker, which is, actually I'd like to give a plug. So friends at DataWire are putting together a Spinnaker Meetup. I think it's a new tool, and it's a growing community around it. We're all going to really benefit from sharing our ideas with each other.
Any questions, guys? Keep it rolling.
I just wanted to say that I appreciate how you balance the
Yes, I've been writing a lot of JSON lately.
Right up here.
You say you're promoting build artifacts rather than code. Where do you draw the line on what constitutes an artifact? So does that artifact include any environment-specific configuration, or is that just an artifact consisting of coded instruments?
So we're using console, which I know we're being told not to use now. But we do service discovery. Exactly, so pull out any kind of environmental specifics out of that artifact. The other great thing about moving to RPMs is, obviously this is AWS focused, but I can create an environment on a developer's laptop and they can pull the same RPM scan and effectively have the same artifacts. And then of course with promoting AMIs through your system, you have a hermetically sealed container that is effectively the same in this test as what ends up in production.
In relation to the RPM there, I agree, I like the idea of packaging packages. Do you run into issues where developers want to develop on Ubuntu?
Yes, we can get into that after a few more drinks, but it makes Ubuntu better.
It makes steps.
Yeah, so.
So do you actually do that? Do you put the packages for the developers to use, or do you just say, no, you're going to use the Java?
We have a service that runs on Ubuntu, but yes, and we do
He
make
doesn't get
packages.
Last question.
How much time do you spend spinning up Spinnaker?
Spinnaker itself is
Like configuring it?
so there's really not much to it. In fact, so the goal here was to most of the work I did around cloud formation was get Spinnaker makes a lot of assumptions, especially around naming conventions. So getting the infrastructure to conform to a certain naming convention. Spinnaker, as long as you hit that naming convention, Spinnaker will see it as a group.
So to answer a question, how much time did you spend spinning up Spinnaker?
Well, what does our stack take to spin up?
No, like how long does it take for one to get started with Spinnaker?
Was involved getting Spinnaker into your stack?
Yeah, what was it, 2 months ago?
Well, the whole thing. So,
Yeah, for the full thing.
So just the Spinnaker part, a couple weeks, 2 or 3 weeks. What?
All right. Hey, so we'll table any kind of questions, you guys. Definitely round of applause for
Dr.
our
Rousseau.
We'll have those slide decks and also their direct messaging on our meetup. So if there's any specific questions you guys have, you can continue the conversations offline. We definitely want to get through. We have Anthony speaking next, so we want to keep it rolling. Guys, thank you so much. Round of applause for Barton Nicholls.
Good evening, everybody. My name is Anthony Spring. I'm the core infrastructure architect at Barton Nicholls. And we're going to talk about continuous entropy. This is merging of CI/CD. Little outline of what I'm going to talk about today. We're talking about the history of the monolithic deploy at YieldBot and where we are today. The architecture, pipeline generation, how we build our artifacts, and then the traditional deployments and containerized deployments, and how they've evolved from when we started the system to where we are today. So a little bit of the history. 2014, single monolithic deployment. Once per day, several hours. Human intervention was the norm. Not very efficient. In fact, still part of that is still driven by the CTO today. Early 2015, we started the decomposition of the monolith for independently built and deployed services. This is what we call our traditional deploy, where you're pulling off a small microservice that's running on an independent host. Maybe there's 1 or 2 services running on that machine, and that's it. Maybe you're running a couple of those machines to deploy this host. Late 2015, we started to containerize our services with deployment into Mesos. We actually waited for Mesos and Marathon to catch up to the containerization processes, so we could actually run containers natively in Mesos and Marathon. And here we are, early 2016, we're full speed ahead of the containerization, microservices deployment, and hopefully by late 2016, all the remnants of the monolithic are gone, and all but a few services will be running inside of Mesos. How are we doing this? Apache Mesos and Marathon is a key part of our CI/CD infrastructure. It's used to run generic and specialized on-demand containers to execute builds. Artifactory, artifact store, highly available and geo-located. So we've actually replicated the data across the United States to the various data centers where our applications run, so we can get our software there faster. And Jenkins, the good old workforce. We actually run a bare bones master and very few physical slaves. The key here is the Jenkins DSL plugin and Swarm plugin. We'll talk a little bit about those later. How do we generate our pipelines? Well, all jobs are handled as an infrastructure as code manner, so all of their components are stored in source control. Works well. Jobs are made up of 2 pieces. You have a job definition and an actual, an Erebus template containing job DSL and some JSON. Jobs are realized by taking both of those, merging them together and generating Groovy, fed into the Jenkins DSL plugin. This allows for change to be iterated very quickly. You can actually make a change to essentially we store it in a repo called dogchow. You can make a change in dogchow, it gets picked up, and then your Jenkins job is changed usually within 5 to 7 seconds. So that if you need to make a change, make a revert, everything's there and you can change your pipeline to suit the needs of your application. So the user wants to make an auto or push button deploy from one environment to another. They can make that change for their application as they need to. And then any combination of push button deploys for getting things in Artifactory, out of Artifactory to the environments, whatever the developer needs. So, super quick slide for those that aren't familiar with Jenkins job DSL. This is an Arabized version of it for one of our Ruby gem jobs. So pieces get injected in. There's our job configuration. So all I need to do is drop this file into dogchow, and Jenkins server is already configured to see that, sees that, realizes that, and this is sort of the output of the job down here in the lower left of the Ruby getting generated, which gets sucked into the DSL plugin and creates the pipeline for this. So we can actually see here. These are the two artifacts, or two jobs that are created as a part of this. So if I want to create a new Ruby gem, I have all my code and everything. I can just create another copy of that, drop it in the right directory, and I have my pipeline within 10 seconds. So in YieldBox speak, all of this stuff, so if you came in and asked me how we do stuff, Senior jobs watch for notifications from GitHub to run Rolf against dogchow to generate Groovy fed into the Jenkins DSL plugin. We love our code names and project names. A lot of thought went into this. So let's talk about the enablement. How does this help the developers? Pro, a single job is all that's necessary to make a Jenkins master viable. When we stand up a Jenkins server, it's stood up with Chef. Chef creates that single job. That job ties it to configuration inside of dogchow, which then pulls in all of the jobs that it needs to then create all of the jobs that it needs. Creating a new job in an existing type. So if I wanted to create a new Ruby gem job pipeline, it's a single file. So one file to create that pipeline. So one other pro, repositories are with well-defined structures can have jobs automatically created for them. So a good example is our Chef repo. We have internal cookbooks, external cookbooks, roles, and various things. It's a well-defined structure. So if I create a new Chef cookbook, we can actually see that change happen. Make a change automatically to dogchow that then gets realized, so we can actually get a build pipeline for a cookbook very quickly as well. And that's without even committing that extra file that we saw in the upper left. That's just making a normal change to our pipeline, or to our source repository. Now the con, creating a new job type template can be cumbersome due to the DSL plugin and abstracting the necessary pieces into Erebus. The Jenkins DSL plugin is hefty, a lot of stuff to do. So you want to give it to a developer and have them jump in, it's very difficult. So that entry-level bar is set fairly high for them to understand all of the various pieces. So we've gone through and we've created this artifact in our system. So what do we do with it? Or these pipelines, how do we use them? So what do we do now? We have this listed process. We have this tool called Dr. Teeth. Everybody familiar with Dr. Teeth? Yes. So what's Dr. Teeth? Dr. Teeth allows for a standardized method for building, testing, versioning, and storing artifacts with full customizability for edge cases. So I can quickly and easily take any of the languages that exist inside YieldBot, which goes from Clojure to Ruby to Go to Node to Python to Chef's a language because it's word. All of these things. And with one command, I know how to build that language. I can say Dr. Teeth build, and it builds it for me. The standardization for each of these languages was created between the primary language users and the core team, which allows us to take their feedback and give them the ability to build artifacts in a safe and sane manner while also not hard coding in Artifactory credentials and all these various things into scripts and helps keep the system moving forward. It's the oldest tool in the chain. It actually predates the pipelines that we just talked about. If all goes well, maybe this is a point in the future. This is terribly hard to see. I apologize. But this is just it's a basic command line tool. Dr. Teeth has a bunch of commands: build, bump, clean, Docker build, Docker push, init, publish version. So you can go into any repository that is configured for building with Dr. Teeth. You say Dr. Teeth build, you're going to get an artifact. As long as you have an underlying environment in place, Node or the Ruby environment, or adding it for Java or for Clojure and stuff, you're going to get an artifact. Here's I was actually building Ruby gem earlier today. Dr. Teeth build. These are all the steps that took place in my directory for actually getting that artifact local onto my machine. So, great. How do we deploy it? Dr. Teeth and the Electric Mayhem from the Muppets. There they are. So Electric Mayhem, enter stage left, and this is how we do our traditional deployments. Members of the band, Chef. Chef creates a directory hierarchy similar to Capistrano, so you have the idea of a current symlink and a bunch of version symlinks underneath, and you move the current symlink to all the various versions as you're looking to move your version for a particular application. It does that directory structure. It then creates the service runner pieces for the application. With dummy settings, it actually starts the application. So when you're looking to do a deploy, do you want to stop the service, do you want to help the service? This takes care of it by starting a dummy application. A good example would be a Node app. For our Node application run traditionally, use strong supervisor. So you run strong supervisor, we run it, and put a dummy application in there that fails all of its health checks, that fails all of its service discovery checks, and registers it there. So you actually see, we deploy foo. Foo is then failing service discovery. We get alerts for it. And it also creates the necessary sensu checks for making sure that foo is actually running on that machine, and that it's running, but it's not in service discovery because it's failing those particular health checks. And then Electric Mayhem, an opinionated wrapper around SSH kit. So it's sort of like Capistrano, but without all the extra Capistrano opinionation. So we added our own. And then Capistrano, like symlink-based deployments, allowing for fast deployments and rollbacks. It allows us to roll forward and roll backward just as easily. Essentially, that was one of the main criteria for developing Electric Mayhem. So let's put it all together. Chef Cookbook gets created, deployed to manage the lifecycle of the application for the hosts or host that's running on. A job definition is created in Dog Chow. You're going to hear all the project names. This creates the build and deployment pipeline, and then the next push to the repo, or the application repo, is going to start the CI/CD pipeline. So, poof, git push happens. Pipeline picks up the commit, Dr. Teeth builds, tests, deploys the resulting artifact. Electric Mayhem takes over, warms the destination hosts for the artifact. This way here we're not taking, introducing any type of service outage event at this point. Updates the necessary symlinks to bring the artifact into play. We then restart or hump the service depending upon what it is. The nice part with something like Node and Strong Supervisor, we can actually hump the process, and it will slowly drain the existing threads that it's running, bring in the new version. So usually your process is actually seamless, and you actually don't fall out of service discovery at all, or lose any transactions that are taking place inside the code. Execute any smoke tests, and then a good example, in the first deployment, now that the application is actually running, it's then succeeding its health checks, hopefully, and then introduces it into console for service discovery and consumption through all the other microservices. Let's talk about the enablement with this. It's very easy to roll forward, roll backward. Just changing a symlink, hopping a service. Standardized build and deployment makes working across products very easy. Standardized application configuration for service discovery by automatically creating the console checks and the sensu checks for entry level into the application. A lot of the legwork is there for the developer. The cons, and these are pretty heavy. Electric Mayhem needs to be told how to handle the deployment for a type. Node's easy. We deploy it, we hop it, and it's done. But for some of the other more complex applications that don't have the ability to hot reload configuration with things, and we're going to actually shut down a process, pull it out of service discovery, let it drain, make sure that we don't lose any requests, bring a new one up. It's pretty cumbersome. Con, knowledge of Chef is required. Big one. Requires someone braining to figure out where an application should live, resources, money, cost, all of these things. These three things were a fairly big driver in pushing forward with microservices. So what did engineering say? Let's microservice all the things with containers. So that's what we're starting to do. Microservice orchestration. 3 primary players for us. Apache Mesos. It's resource management, super high level, with a couple of service runners. Marathon and Singularity. I don't know if there's any HubSpot guys here, but thank you. Our platform team loves this tool. So Marathon and Singularity, so well, M&S essentially is what you'll hear going forward, allows us to take a very basic configuration for, say, running a Docker container, and say I want to have 3 of them, and if you're familiar with Nomad and various things, I want 3 of them, and I want it distributed this way, and I want guaranteed availability of 2, so if you need to do a new deployment, we're only going to pull 1 down at a time, guaranteeing service availability, and it'll handle all of that abstraction for you with a very simple JSON configuration. So the 10,000-mile view, frameworks for running containers and Mesos, the ability to configure necessary resources of an application on a job-by-job basis, and the ability to configure a container lifecycle to guarantee a certain level of availability. So you see what we did there? There's no need to self-manage HAF services. There's no chef, and there's no underlying resource management. So the 3 cons that we had on the previous traditional deploy are gone. Slightly happy developers. So, first thing first, how do we actually get jobs into the frameworks? So, another infrastructure as code approach. We have a pair of tools that we've open sourced, that have been around for a little bit, Scooter and Singularity Pi, that take JSON blobs for the corresponding frameworks and just ship them to the REST APIs for the corresponding frameworks. And so here, your job definition is stored in Git, make a change, pipeline picks it up, ships it up, and let the framework handle deployment. So let's talk about build and deployment V2, taking all this stuff into account. Dr. T still builds the artifacts with the additional step of getting into a container with the necessary runtime to push, and then pushing the container to Artifactory. But instead of having Electric Mayhem take over, we just have an additional step in the pipeline that actually updates the Marathon or Singularity job in the corresponding version for the artifact you just built, makes that change in the necessary environment file, pushes that to Git, and then the pipelines from the previous slide pick that change up and push it off to the environment necessary. These pipelines also respect any other changes that are made to them. So if we're just, our pipelines only bump the version, so if the user in the meantime wants to then change the CPU allocation or memory allocation or some method for how they're distributed across the cluster, they can make all those changes simultaneously and we're not going to step on their toes. How do we put it all together? Well, we only really need 2 files now. A job definition in .chow, which actually creates the build and deployment pipeline for the application, which can be as small as 5 lines. And then a Marathon or Singularity job definition, which is a little bit more verbose, is created in our repository called Skeeter. And from there, any deployment failures that result from an artifact being deployed into an environment gets handled by the framework itself and the email notifications that it sends out when it can't deploy, and monitoring for those services and availability. So what's next for looking at all this stuff for the road that we've gone on? Replacing the DSL plugin with a newly revamped Jenkins pipeline plugin to make entry level easier in terms of removing a lot of the extra verbosity to get something that's a little bit more Travis-like. And looking at alternatives for deployment visualization, orchestration, and verification. That's the nuts and bolts. Any basic questions?
What led to the dual scheduler system for releases? You have Singularity and Marathon, which have a large number of classes.
Sure. 2 different people.
2 different people?
Yeah, no, we actually started off with Marathon, company-wide, and platform architect, like Singularity, there are some different features that they both offer. My team works primarily with Marathon. We don't need some of the extra features that are inside of Singularity. And with multiple teams using that software, we wanted to at least try to keep I want to keep my team cutting edge on Marathon, keep pushing that version to vet it before it goes out to other teams. And so they're sort of bleeding edge Singularity, and we're bleeding edge Marathon.
Do you guys see conversion at some point, or do you get a full stack?
No, I don't see them converging. Dave, I'm sure you're watching out there. He really likes Singularity, and I don't dislike Singularity. Another team that doesn't use Singularity uses Marathon. But a few of my guys on my team, are biased one way or the other. But we actually run both in core apps, core infrastructure, our cluster. We do run both. So I do like Singularity for time-based cron type jobs, and Marathon for my long-running processes.
Okay.
How do you manage setting for containers, environment by environment, process by process?
Sure. Each configuration file is handled on an environment by environment basis. So if you're running foo in dev and production, you're going to have two configuration files. This way here you can specify the resources for those, or even service discovery parameters entirely different. Now, unfortunately, it's not super dry in terms of you do have almost copy and paste, with 90% of the configuration is identical. So you can get some drift in there. However, each team manages their configuration files, or each product team manages their configuration files. So it's small.
So how does the config file end up on the machine?
One of the pipelines. So using some yield bots, all of our configurations are stored in a repo called Scooter, and it's sort of directory structure based upon environment, one region, and various things. And we have the opinionated hierarchy in there. So as soon as one gets created a file, that file comes in, Scooter or Singularity, essentially push it, just a REST call, glorified wrapper around like a curl that pushes that to the REST API, and then for the case of Marathon, then accept it or deny it if there's some syntactical error, and or the parameters inside the job configuration.
Same time to design workflow V2, what made you decide to keep Dr. T to crash electrically?
Just a matter of time. Dr. Teeth appreciation, in that it was a quick way to standardize building and really and pushing it out of the factory. Where with how we have all templated now, we could easily remove all of that cruft and have that inside of the job template. But it says Dr. Teeth build, Dr. Teeth push is significantly easier than for NPM. You're going to do your clean and you're building and you're testing and all these various commands. A couple of commands inside of there makes it easier. It's really up to each team too. I see it going away at some point.
Since you mentioned Mesos and Marathon, have you tried Mesosphere or considered open-sourced DCOS?
It's on the roadmap to evaluate, but it's not something that I'm going to jump right into the pond with. We have been running Mesos for 20 months in production, so we're relatively happy with where we are, sitting on top of CentOS and things like that.
Why do we have a design of directly going on the environment test made? Because write Ruby libraries or something that can really be here before.
Sure. Most of my team comes from a Ruby background, chef background, so we're familiar with Arrows. It could easily be converted today to Go templates or any other tool to generate that. It was just what was in our wheelhouse for taking JSON and something to generate Ruby to make those templates. Those drawings.
Why the template? Because it's written in a nice language, and you can just write a function in that in the template.
We could, but don't have to write Ruby. So, not that I'm going to show language opinionation, but Groovy is not the wheelhouse of anybody in Yobot. It's just how we took the approach. I could have. but I would have had to say and Scala as well. So.
What are you using for service discovery?
So we currently use Console for service discovery. And yeah, we do hit the same issues that...
Can we actually spell them out? Because we're always saying it's not good, but we don't say why.
Well, I forget the gentleman, the same exact reason why he was talking about with console service discovery. You do have that disconnected. Your console service goes down, and your agent's only going to serve stale requests for as long as it's configured. You don't want to serve stale requests for 2 hours. With how the console agent's currently designed to serve stale data, regardless of whether it's actively communicating to the leader.
All right, that's enough for tonight. Thank you. Thanks to all of us.
Go ahead, can I do really quick?
Yes.
Can I do my demo?
Yes.
Okay. So before everybody goes, I was hoping to do this maybe on a more formal scale. But some of the Wayfair guys will be a little bit happy. We're actually getting ready to open source a new driver for Test Kitchen. So how many people are familiar with Test Kitchen? Okay, great. So how many people, what frameworks do you guys use for Test Kitchen in terms of infrastructure provision? So maybe you're using Vagrant or VirtualBox or EC2 or OpenStack. We're getting ready to open source Kitchen Marathon, which is a marathon driver for Kitchen. It's going to launch Docker containers. So if you want to sit there and launch infrastructure into, say, a dev environment and run all of your unit tests against it, you don't need to run the entire platform system on your Mac. When you're dealing with terabyte data sets, you can actually have it running in dev and launch your tests, use that dev data, and test what you need to test and go from there. I'm going to do a quick test just to show you guys, and hopefully we get to tomorrow. I'll push the public button for everyone. Going to connect in here to one of my systems here really quick. And this is actually a marathon running in our Atlanta data center. There's a bunch of stuff running in here already for those that are familiar with it. We'll get some Jenkins stuff and various things, internal tools. But the important ones are Kitchen. So let's get this big. Let's grab this command. What this is going to do, I'm actually going to run a Kitchen bake against the DevOps Meetup cookbook. And this is currently going through, looking at all the test suites that I have for Kitchen, Test Kitchen set up. And you can see in the background that I'm now talking to the Atlanta data center, and it's spinning up my containers. The entry level for these containers is, as this is, to run SSH. Unlike if you use Kitchen Docker, which can use Docker exec to keep things inside of it, this needs SSH inside of the container. So it's currently spinning up the containers. Once they come up, it will rsync the files into there. So we see the container actually started at this point. Chef is starting to converge. So the same way you use your Kitchen workflow for all of your other providers, you can now use it for Marathon. Any questions really quick? I know we all want to get home. It acts the same exact way as if you were to run Docker on your local machine. So I can take these tests, change my Kitchen provider to Docker, or to VirtualBox, however I want to use. It's going to run and provision the same steps based off of your Kitchen test configuration. But when you're coming to looking at for tests that need to consume a massive amount of data, or services that aren't really something about like having 30 SQL databases available. Now they're available. They're in my dev environment, my production environment. I can spin up my test, my test container, run my tests, and actually see what are the results. And it's actually what's happening right here. So hopefully it's really gems tomorrow. Short on documentation at this point. Thank you.
Anthony and all the speakers. Thanks to
Thanks to Wayfair for having us, for having great food and drinks. And thank you all for coming. This meetup is nothing without the community. You can continue the conversation on the Slack room. Just go to bostondevops.org. We'll be posting slides and videos online for you to watch. There's some other stuff. I'll send an email tomorrow to Meetup, so you don't forget. Thank you.